Hi everyone, Robin here. This is a knowledge sprint, so we're just going to look at searching and sorting algorithms, so let's get going. Okay, if we look at a linear search first of all, we're going to do a search for one. What we've got here is unsorted data, that's totally fine. And all we're going to do is we're going to check with the first item, is it a match? No, it's not. Check with the second, is it a match? No, it's not. Check with the third, is it a match? No, it's not. And then we find it in the fourth position. What we've meant is we've done 4 comparisons. So really easy, nice and straightforward. Okay, let's move on. Okay, we've got a binary search now. Notice that the data is sorted, and it absolutely must be. Again, we'll do a search for 1. What we've got here though is we need to declare a lower bound and an upper bound. So in this case, it starts off with the lower bound being 1 and the upper bound being 9. What we then will do is calculate the midpoint, which in this case will be 5. So our mid is going to be 5. What we then do is compare 1 with 5, which isn't a match. In other words, we need to then keep going. What this means though is when we compare 1 with 5, 1 is less than 5, and therefore we know it's going to be on the left-hand side of the data. So in other words, we can get rid of that right-hand side. What that means then is we have a lower bound of 1 still. We now move the upper bound to 4. We now have a new midpoint of 3. And again, we compare 1 with 3, and again, no match. Because 1 is less than 3, we therefore know that 1 is going to be to the left-hand side, so smaller than the 3. And in other words, we know that it isn't going to be the 3 or the 4. What this actually has meant is we now have a lower bound of 1, a upper bound of 1, and actually our midpoint is 1, and therefore we have a match. Equally, if this stage there was no match and we had no more data left, we know that the data set wasn't there. The data wasn't there in our data set. Okay, let's do a bubble sort then. So with the bubble sort, we do comparisons. In other words, we constantly compare the data with the one that's next to it. If it's greater than, in other words, if the left one is greater than the right one, they'll swap. Otherwise, they'll remain in the position they are. 8 is greater than 4, and therefore they will swap. 8 is greater than 3, and therefore will swap. You can imagine 8 is moving along now. 8 is greater than 1, therefore will swap. 8 is currently positioned here, just so you can keep up with me, if you like. 8 is then compared with 5. It is greater than it, so it will swap position. 8 isn't greater than 9, and therefore will settle here and stop. 9 takes up the mantle then of the one being compared, and 9 is greater than 6, and therefore will swap his position with 6, as you can see has happened. Okay. Because swaps have happened, we start again, so that was considered a pass at that point. We then start again. 4 is greater than 3, so we'll swap. 4 is greater than 1, so we'll swap, but 4 is less than 5, therefore we'll settle its position. Just like before, 5 takes over. 5 is less than 8, however, so we'll stay where it is. 8 is then compared with 6, it's greater, and therefore they will swap. 8 is less than 9, and therefore now has found its position. Pass. Okay, start again. So 3 is compared with 1, we'll swap. 3 is less than 4, so we'll then stop where it is. 4 is compared with 5, we'll stop where it is. 5 will stop with where it is, 6 will, 8 will, and 9 will. So we still had a swap, So therefore, we again have another pass. The downside of bubble sort is that we need to confirm this. So we need to then go through again, check in, has there been any swaps? And then there's been no swaps, and therefore we've completed it. Okay, an insertion sort then. Logic of an insertion sort is if I put a line down here, the 8 is sorted because there's nothing greater or smaller than it, if that makes sense. The rest of them can be deemed to be unsorted. Okay, so in other words, what we're going to do is keep adding a data item to the sorted side. So we compare, so we bring 4 into the sorted side, we compare it with 8, it's less than, and therefore will sit on the left hand side of 8 in our sorted side. We now have a data set like so. We then bring 3 across, 3 is less than 8 and less than 4, and therefore will sit in front of the 4. So 3, 4, 8, 1, 5, 9, 6. We then bring 1 across. So 1 is less than 8, it's less than 4, it's less than 1, and therefore will sit at the front. Like so. 5 is then brought in, so 5 is less than 8, but it's greater than 4. So in other words, hence the name, it will be inserted between them. So therefore we'll have 1, 3, 4. The 5 is inserted between the 4 and the 8. And then we continue. So again, 9 is compared. 9 is greater than 8. So therefore will be placed after it with just 6 remaining. And then we bring 6 in. So 6 is less than 9, it's less than 8, but it's greater than 5, and therefore will be inserted here, and therefore 1, 3, 4, 5, 6, 8, 9 is our fully sorted list. Okay, so this is a merge sort now. So we take our list and we're splitting it in half. I've got an odd number here, so therefore I'll have 4 on one side and 3 on the other. There's no rule about that, but it makes sense to do it the left-hand side. We use the left-hand side most often in algorithms, don't we? And therefore let's do the same here. So we've got 8, 4, 3, 1, and then 5, 9, 6 on the other side. Again, we need to split these up. So we'll now have 8 and 4, 3 and 1, 5 and 9 and 6. Now we split it again. So we're going to have 8, 4, 3, 1, 5, 9 and 6. Now that we've fully broken it up, we now want to bring it back together. So we're going to do comparisons. So in other words, we're going to compare 8 and 4, and therefore 4 is less than 8, so we'll go in front of it. We're going to compare 3 and 1, so in other words 1 and 3. We're going to do 5 and 9, and then finally 6 is on its own. Again, we bring these together again. So what we're going to do here is compare the 1 with the 4. So the 1 will go first, Then we do the 3 with the 4, and therefore the 3 will go in. The 4 then comes in, and then the 8 comes in. In other words, just to make clear what I'm doing here, I'm always comparing the leftmost item first. So in this case, we've only got one leftmost item in this, the 6 on its own, but we compare 5 with 6, so 5 is less than, then it'll be the 6, and then it'll be the 9. Going to be perhaps more clear what's going on here, so I compare the 2 leftmost. The 1 is the smaller, so we've got a new leftmost, if you like, of the 3, so that is again the smaller. The 4 now is the leftmost, and again is smaller. The 8 is now greater than the 5, so we're going to bring it from this side. We then look at the leftmost here, now is 6, again it's the smaller. The 8 now is the smaller, and then finally the 9 sorted. Okay, I'm going to show you a quick sort method now. The quick sort method I'm showing you here is a method that's used by further maths students, and therefore makes sense because quite a lot of computer science students will do further maths. It therefore makes sense that we learn this method. It saves you for both subjects, makes life a lot easier. The thing with a quick sort is we use a pivot. It's statistically quicker to use the midpoint than it is to use either the left or the right side. There's no rule about that, but what I would do is be consistent once you've decided. So if you always go left every time. If you're going to go right, go every time. I'm going to go with the midpoint. So in other words, I'm going to use 1 as my pivot. What we're doing here is we maintain the order. So in other words, 8 is greater than 1, so we'll go on the right hand side of 1. 4 is greater than 1, so we'll go on the right hand side. But notice I've put it still out of order. I haven't tried to do this. I haven't tried to swap them here at all. They're just maintaining the order. So again, 3 will, 5 will, 9 will, and 6. So you can see that the 1 has actually fully gone to the left hand side. That's now in its correct position. In other words, everything to the right of it is greater than it. There is nothing to the left. What we do now is pick a new pivot. Again, let's go with the middle. As you can see, I've got an even number here, so I haven't got a middle one. So in that case, I'm going to always go to the left-hand side. So in other words, I'm going to choose 3 this time. So again, I'm going to compare. I'm comparing the 8 with 3 is greater than, so it's going to go on its right-hand side. I'm just going to draw it down here, so I'm just do the 1 and the 3 there. So notice I've just underlined them both because I want to make it clear I've already had them as pivots. So 8, 4, 5, 9 and 6 have all gone on that side of it. Again, I'm now going to pick a new pivot. So I'm going to go with, again, the midpoint. So I'm going to go this time with 5. So 8 goes onto this side of it. 4 will go onto the other side, or stay on the side it is currently, if you like. The 9 will go on this side, and then the 6. And then again, those 1 and the 3 were already in the correct position. So now I've used that as a pivot, that as a pivot, and the 5 as a pivot. You can see the 4, if I use that as a pivot, it doesn't actually move, so I don't need to do anything with that. If I use, again, the midpoint here of 9, 9 obviously is greater than 8, so the 8 can stay where it is, but the 6 is also less than 9, so therefore it will be written out like so. But the 9 is in the correct position. Again, I've already had 1, 3, 4, 5 and 9 all as pivots. Now I just need to do 8 and 6. So it doesn't really matter which one I pick, but I'm going to go with 8 just to be consistent with always picking the left hand one. I then compare 8 with 6, and obviously they're the wrong way round, so I'm just going to swap them round. Bring the numbers down to join it. And I've now had every single one, barring 6 as a pivot. Obviously when I do pivot as a 6, it's not going to move. It's now sorted. Okay, well, I just wanted to say thank you for watching. I really hope you found it useful and really hope you've learned something. Please do like and subscribe, and I'll hopefully see you again. Thanks a lot. Bye.